Good morning, everybody. My name is Nagachandrika Pallam, M.Pharmacy. So, today topic is pilot plant scale up for the solids. So, pilot plant consideration for the solids. So, in scale up of a manufacturing of a tablet capsules and from the experimental laboratory batch sizes to intermediate and large scale production, each stage of the operations must be careful condition. That means if this is the solid dosage form. While handling in pilot plant consideration what we have to consider while conducting a pilot plant for the solids. So in scale up the manufacturing of the maximum solids are two types. Solids are maximum tablets, capsules, pellets, like that. Okay, so in scaling up of manufacturing of the tablets and capsule from experimental laboratory batch size to intermediate and large scale of production, each stage of operation must be careful consideration. That means the when this process in this pilot plant scale up process, what will happen, this laboratory scale to intermediate batch scale and intermediate batch scale to large scale production. So in this while handling this process, we have to come across various stages. So in these stages you have to be, the operations should be carefully handled. So the here see in the small scale what will happen, the formula is the same. Formula is in small quantity in laboratory scale. Formula is in large scale in formula is increased in formula in large scale. So what will happen, but the process is same and the equipment is same. So ultimately the output is different. So the same process, same equipment, but a different performance when the amount of the material is increased. So when we are increasing amount of the material, raw material, if our formula is we are increasing with the same process, same equipment, it will give the different outputs. The major changes that utilize the techniques and equipments that either unavailable or the unsuitable on the lab scale. So the following, what are the different unit operations we are performing in this solid dosage form production? So let us discuss what are the stages of the production of the solid dosage form, mainly in the tableting, what we are doing. Okay, material handling. First one is the material handling, how you are handling your materials, that is very very, very important. Next one is the next one is the dry blending. Next is the granulation, drying, and size reduction and a reduction of the particle size, and special granulation techniques, and the dry blending, and direct compression and slugging. These are the different things we have to discuss. Okay, before going to this in detail process, first of all, what are the different methods for the tablets? Once we will recap. Okay, what are the different methods? Okay, how you are preparing in a different methods. See in this, the API combining with the excipients, we both the API and excipients are blended together. That is the first process. So if it is having good flow properties, then we can directly go for the direct compression. Direct compression to, after direct compression, we have to mix with the lubricants and lubricants to compressing the tablet. So when we have to go for the direct compression, after blend with the lubricants, we will compressing into a tablet. After the tableting, we can go for the coating to packaging. So here see, if the blend does not have a poor flow properties, if it is having poor flow properties, what will happen? We go for the granulation methods. So what is a granulation method? Again divided into two methods, dry granulation and wet granulation. See, why we are going for the dry granulation and wet granulation? I will give one simple example. Uh, in blending, if the excellent flow properties, what will happen? It will be flow very excellently. It will flow and it will not stick to the hopper. So if it is not stick to the hopper, what will happen? It will directly flows to the compression die cavity. It will be reaches to the uniform size. It will be reaches. So what will, when we are compressing, we will get uniform size tablet. So if the flow properties are poor, what will happen? It will stick to the hopper only. Some material will be stick to the hopper only. Then what will happen? This the improper flow of the material to the die cavity will leads to reduction in reduction of the tablet size. What will happen? Improper particle size will be happen. Improper particle size leads to then the low pharmacological action to low therapeutic effect. So the flow property, the drug should be uniform size, then only it will gives the correct pharmacological action and also the correct therapeutic effect. So flow properties are very important. If it is not showing any poor flow, if it is showing poor flow property, what we have to do? We have to increase the flow properties. How we will increase? By granulation method. By granulation method we have to increase. So what is granulation? See, I will give one example. If you are taking atta means chapati atta. If for example I am telling, so if you are taking atta and the peanuts, so with which material will flow very fast excellently? Which material will be flow? Obviously peanuts will be flow faster. Why it is happen? Because of it is having particles, the size is, because of the size it will flow excellently. So, because of the fines, the atta will not flow properly. So how we will rectify? If we are increasing the particle size, these fines we are converting into a increased particle size, what will happen? The flow properties automatically increase. For that purpose we are converting into a granulation. Granulation is nothing but the formation of granules, converting into a granules. Granules is nothing but the increased size. So here granulation methods are two types. Okay, dry granulation, wet granulation. So in dry granulation, here particles, how the particles will be aggregated. His granulation is nothing but the aggregation of the particles. How the particles will be aggregated, how the particles will be combined together. So how it will be? When we are, it will not happen. But when we are adding some material, that is nothing but the binding agents. When we are adding the binding agents, these particles will be aggregated. So these particles are, after aggregating these particles, what will happen? This will be if we are adding the dry blenders, it leads to the dry granulation. If we are adding the wet blending solution, wet binding solution, that leads to the wet granulation. So when we have to go for the dry granulation, when we have to go for the wet granulation, if the material, raw material is in hygroscopic in nature, then what you have to do? We have to go for the wet granulation. So well, if it is in a dry condition, what will happen? We have to go for the dry granulation. So this is the main concept. So So after wet granulation, we have to go for the milling to drying to bind with the lubricants. So you have to remember here one thing: the lubrication is nothing but the lubricating for lubricating the powders. So with the lubricating the powders. So with the lubricants, the tablets will be this lubrication, always lubricant should be added at the last stage of the last stage of this last stage, and before compressing these tablets, we have to lubricate this compound, lubricate with the API and other excipients. We have to lubricate with, and after that only we have to compress. So in each stages, see, in a direct compression and granulation, the lubrication is the last stage. Okay. Next one is binder. If it is capsules, this blender, if it is having a excellent flow properties, what you have to do, directly we have to go for the filling. Okay, with using of into a filling into a capsule shells. So what are the capsule shells we are using? Means hard gelatin capsules we are using. So by this locking method, we are making into a capsule. The capsule goes to the packaging. Here, this is the difference between the direct compression, dry granulation, and wet granulation. In dry granulation, what will happen? Direct compression, what will happen? API, lubricants, binders, disintegrants, we are mixing all together and compressing. Okay, so because of the excellent flow properties. Okay, in dry granulation, what you are doing, API mix with the diluents, binders, and disintegrants. After mixing, after blending after blending, it have to subject to the roller compact. What it will do, it is nothing but the dry granulation. How we will differentiate with the wet granulation means for forming a slugging is the main difference between the wet granulation and dry granulation. Okay, slugging, in dry granulation, what we are doing, slugging and formation of the slugs, means before compressing into a tablet. How? So here we are not using any wet solution, and then how the particles will be aggregated? We are using binders we are using, but the how the particles will be aggregated, if it is in dry granulation, how it will be aggregated? So for that purpose, we have to compress. So compressed by the roller compact machine. So this also called as a pre-compression, also call it as a pre-compression method we are using in dry granulation. So compress like a slugs, how it will be? It will like a for example, it looks like a ice cream sticks. Okay, like that slugs will be prepared, means the particles will be aggregated. So after particles aggregated, we have again milling or the screening we have to do. So because the particle aggregation we have to separate. Okay, that is by the milling. Again we have to convert with the powder. After that, adding with the at the end stage, we have to add the lubricant and glidants to increase to lubricate the uh, uh, die cavity, and then we are compressing. Here when wet granulation, see what you are doing, API, diluent, we are mixing. After that, we are wetting with the binding solution. Binding solution here is nothing but the binder with a water. We are adding the binding solution to this blender. So blending, when it is wetted with the binding solution, we have to go for the, it will form a lumps. These lumps we have, this lumps is nothing but the granules. We have that granules, we have to be, that granulation will be happen. So that granules have to be sieving. Okay, we have to do sieving. So after sieving you will get a proper granules. So that wet granules should be dry should be dry in a dry with a dryers. After that these we are forming a different particle sizes you are getting in granulations. So large granules, small granules, so different granule sizes you will get. So what will happen, you want to you want to make it into a uniform granules. What you have to do, again you have to go for the screening or the milling. Okay, screening or the milling. Here double sieving we have to do. After that we have to go for the milling. So after milling it mix milling, finally we have to lubricate with the lubricants and the disintegrants, and we have to blend again, and we have to go for the tablet compression. This is the methods involved in tablet compression method. So while conducting a dosage form, we have to perform a different stages, stages of operations we have to perform. So while handling these operations we have to be very careful. So what are the steps we have to take care? So material handling. So first you have to blend with for the blending you have you need a materials. So materials, how you are handling, so with the how you are transferring the materials from storage area to production area, how you are handling. Okay, that is very important. In the laboratory materials, simple scooped or the poured by the hand. So within the laboratory conditions, what you will do, just you will with the spoon, also with the pouring with the hand also you can handle. But in intermediate stage, large scale, that means it will be 30 cases or 500 cases. What will happen, you need some special equipments to carry the material from storage area to the production area. So while carrying these materials, so you have to be very careful. So in this system used, so if a system is used to transfer material more than one product, steps must be steps must be taken to prevent cross contamination. If you are handling one material, means they, there is no need to care. But if you are handling more than one material, more than one material, what you have to do, that materials should not be contact with each other. That leads, if it is contact with each other, what will happen, it leads to contamination. So contamination leads to microbial growth, or the poor production, and quality will be reduced. So any material handling system must be deliver accurate amount of the ingredient to the destination. So while handling these materials, the proper amount of the ingredient should be destinated, means delivered to the production area. So then only for the formulation purpose, the material should be carried from storage area to production, and it should not be degraded. That means it not be, the product should not be reduced. If you if in storage area 5 grams is there, means that should be, while transferring, after transferring also it should be in 5 grams. It should not be degraded. When if it is degraded, means the material loss will be happen. Material loss leads to improper uniform size, and batch size also reduced, and it leads to the leads to the less therapeutic effects also. And the type of the system selected also depending upon the characteristics of the material. So which system you are for carrying this material handling, which system you are using, that depending upon the what materials you are using. Okay, that depending upon the what materials you are using. So if in more sophisticated method of handling materials, such as vacuum methods, vacuum loading system and a metering pump and a screw feeding system. While handling these sophisticated handling methods, you should be very careful. So there should be a no cross contamination, or the minimal cross contamination should be there, or minimum loss of material should be there. So the material should not be lost. Coming to the dry blending. In dry blending, see here, in dry blending process we are using the why we are blending these different materials are blending. How it is blending? See here, different material, here different material. So small particle size will adhere to the coarse particles. So small the fine particles is adhering to the coarse particles. In dry blending process, using the binary cohesive powder mixture, which contains a two different sizes. Cohesive means same compound but different sizes we are mixing, blending. Okay. So the cohesion is nothing but the attraction between the two compounds. So it is well known that the fine particles adhere to the preferentially on the surface of the coarse particles. See here, fine particles adhering to the coarse particle, means fine particles is stick to the large particles. So how it is sticking? This sticking process, we call it as a interactive mixture process, we call it as a. So the blending of the fine and coarse particles break down agglomerates of the fines and coarse powder to produce an electrical charges by contact and collision between the particles. So how it is adhere or cohesive to these materials means, so by when it is interacting, when it is contact with or the collision between the particles, what will happen? The electrical charges will be produced. Because of the static electric charges, it will stick to the to the large particle, means the coarse particles, it will be stick. So the blending of the fine or the coarse particles break down the agglomerates of the fines. So these fines will be attacking to the coarse particles. So the fines will be breakdown. So there is no granules will be formed. So this is the blending process will be happen like this. So in dry blending process, using the binary cohesive powder mixture, which contain a different sizes, it is well known as that the fine particles adhere preferably on the surface of the coarse particle. This type of mixture is called a interactive mixture. Same thing I also kept here. So next. So dry blending, the powders to be in dry blending, the powders to be used for the encapsulation or to be granulated prior to the tableting and encapsulation must be well blended to ensure the good drug distribution. That means after the if the powders is going for the encapsulation, the process is further going for the encapsulation or the granulating process, what we have to consider, the blend, the well blend should ensure the good drug distribution. The good drug distribution, when it will happen, when it blends properly. So while conducting a encapsulation method or a granulation method, what will happen? It should be a good drug distribution should be ensured. So when it will happen, when it is well blended, it will be leads to good drug distribution. Inadequate blending at this stage causes the variation in potency. So it should not blend very low or very high. So if it leads to the uniform variation. So drug content will be content will be decreased or the increased. So these steps should be taken to ensure that all ingredients are free from the lumps and agglomerated prior to the dry blend. So what we have to do before blending, these powders should not have any lumps or the agglomerates. Then what will happen if lumps and agglomerates present, means it leads to improper mixing will happen, improper blend will be happen. So for that reason, before going to the dry blend, we have to be avoid these lumps and agglomerate. So see, if you are for example, I'm telling, if you are preparing a atta dough, what you have to do before going to your atta dough, you have to be screening with the screener. You have to sieving with the sieving machine. So why we are doing, to avoid a lumps or a any coarse particles. So we are separating from that atta. So fine particles will leads to fine dough. Fine dough leads to fine chapatis. Like that, here also we have to get a fine with the good blending only. We will get the good distribution of the tablet. Tablets also have leads to good distribution. So for a good blend, what you have to do, well blended, what you have to do, we have to avoid the lumps. So if the failure or removal of the breakgrounds of the agglomerates, if it is failures, what will happen? It causes to flow property problems. Then you have to go for the granulation method. Why we have to increase these different steps directly? If we are avoiding before only these problems, we can increase the flow properties. If the because of the materials, sometimes it will leads to flow properties very low. So at the time we have to go for the granulation. But the powder having good flow properties, then it is because of the lumps and agglomerates, it is not showing any flow properties. Means what we have to do, we have to avoid these lumps and the agglomerates. So here non-reproducible compression and capsulation. When encapsulation leads to detrimental effect on the content of uniformity of the product. So for these reasons, screening or the and the milling of the ingredients usually take the process more reliable and the reproducible. So for these reasons, screening is very, very necessary. Here the scale up considerations, what do we have to do? The three major considerations in blending. What is the, how much time you are blending, how much time. If it is more time, means it will leads to flow properties, and if it is less time, means it will not blend properly, it will leads to flow properties also very low. If it is a speed, means it will so you have to maintain a correct accurate blending time, you have to maintain. So blending loading speed, so how much speed it is rotating, you have to so accurate speed time. It should not be very fast, it should not be very slow. So the proper accurate blending load speed should be there. So next one, blending size. So more compound you should not dump into the blender. So if more compound you are blending, means the improper blending will be happen. So if it is very less, means the blending also will leads to some problems. So like that, we have to maintain proper blending size. So machine will not be run properly, so it will make some sounds like if you are incorporating in low size, means so the timing of blending is important, blending loading speed is important, the blending size also very important. The problems of the improper blending, what will happen if improper blending leads to flow property problems? We will come across flow problems through the equipment. It will stick to the, if it is not If it is not properly bent means what will happen, the flow properties will be decreased. If it is more means what will happen, more compound will be available to this, and wastage of the compound will happen. So it should not be more or less, it should be in a proper condition. Next to the non-reproducible comprehension. What is this non-reproducible comprehension means? So we can't reproduce, we can't make it into a, sometimes what we have to, if any problems leads, we can rectify, and if we are adding some materials, we can by that we can reproduce. But sometimes what will happen, non-reproducible comprehension, it will leads. Okay, now no content uniformity, that will, if the flow properties is more means more, the more compound to the more material will reaches to the die wall, that leads to the edges, edging will be happen. So it leads to the increased content uniformity. If it is low properties means what will happen, it will leads to less uniformity content we will found. So these are the problems arising for the blender. So what are the different equipments we are using? V blenders, double cone blender, slant cone blender, bin blender, arbitrary screw blender, and vertical and horizontal high intensity mixers we are using. See, these are the bin blender, and this is the heavy planetary mixer. This is okay. This is the ribbon. This, so the cutters will be in a ribbon like. Okay, this is the mostly our pharmaceutical field we are using V cone blender or the double cone blender. Okay, so this is the V cone blender, this is the double cone, two sides it will be coned in size. So the like by this this double cone blender we are mostly using in the formulation purpose.